We can use a number line to help us understand the addition of integers. Consider this problem. 2 plus 3, well, we know that 2 and 3 is 5. But on the number line, it would look like this. We would start at 0 on the number line, and adding 2 and 3 would work like this. We would begin at 0 and go a distance of 2, and here we are. And then from there, if we're going to show the addition of 3, then we begin here and go 1, 2, 3 more, and we end up at 5 as expected. Now, in a similar way, we can collect or add -2 with -3. You see, if the negative direction is this way and the positive direction is that way on the number line, then here's what we can do. -2 with -3 means start at 0 and come out to -2. That's here. And then from here, go with -3, collect with it or add to it -3, and we get here at -5. So -2 with -3, -5. Another way to interpret this is that the temperature is -2 outside, and it drops another 3 degrees. Well, it's now at -5. Consider these problems: 7 plus -2. Now, once again, we can use the number line to help us decide what we get here. Let's do that. 7. We're going to go to 7 and then collect -2. That means we're going to come back this way too. So let's see. 7 with -2 means we start at 0 and go over to 7, and then the -2, we're adding -2 with it, puts us back to this position, 5. So 7 with -2 is 5. And that's pretty much what we would expect, isn't it? Because after all, 7 minus 2, you see, if you will, it's shown as an addition problem, but we could think of it as just subtracting 2 from 7 to get 5. All right, now what about -7 plus 2? Well, once again, on the number line, and let's just visualize it here. Let's just think about it. We would go to -7. From 0, we would come to the left 7 units, go to -7, and then add 2 means go to the right 2. So we go to the right 2 from -7. Gee, we end up at -5. Now, there's something I'd like you to notice about these problems, that in these two problems, we had the same sign. This is understood to be +2, and this is understood to be +3. I can emphasize the idea by introducing parentheses here if I want to. So we're collecting or adding two positive numbers, and we get as a result a positive number which is just the sum of 2 and 3. You see, we just add those digits 2 and 3, we get 5, and the answer is positive. Now here we are actually adding two negative numbers. I can emphasize the idea like this: -2 with -3. You see, we're adding two negatives and we get a negative result. You see, -2 with -3. Now, the 5 can be thought of as just coming from 2 and 3. You see, add those digits and you get 5. And the sign here, negative, is the same as these two signs. I think that's kind of important too. Now, in these problems, we have a positive number being collected with or added to a negative number. And here it's a +7 with a -2. And we get a positive result. But here we have -7 and +2, we get a negative result. So sometimes when we add positives and negatives, we get a positive result. Sometimes when we add positives and negatives, we get a negative result. So sometimes positive, sometimes negative. Now, how can we tell? Well, there are a couple of ways to deal with this. I mean, we want some strategy for adding integers that doesn't require us to go to a number line and move along the number line. After all, what if we had a number like -172? You see, we would have to make an awfully long number line to accommodate that. So we want some kind of strategy to deal with this. Here's what I want you to notice. I want you to notice that when you are adding integers which have unlike signs, that is, one is positive and one is negative, you are really taking the relative difference between the digits involved. Now just ignore the signs for a minute and think about the digit 2 and the digit 7. You see, 5 is just the difference between 2 and 7. Take 2 from 7, you get 5. All right, and the sign of the 5, it's positive here. The sign is the same as the sign of the number that has the largest digit. You see, 7 is a larger digit than 2. You see, and it's positive, and the answer is positive. Now, let's look at this one with the same idea in mind. We have one number is negative, the other is positive. So we have unlike signs involved in the collection or the adding process. Okay, we take the relative difference between the 2 and the 7. Take 2 from 7 to get 5, and the sign here, negative, comes because we have the larger digit has a negative sign. You see, so that allows us to formulate some rules for adding integers. And let's write those rules down. Now, I want you to understand this, that when I talk about digits, I'm talking about just the digit involved in a positive or negative number. That's the same thing as saying the absolute value of the number. But I think it's a little easier for us to get into the problem and to understand it quickly by saying digits rather than saying absolute value. But every time I say digit, I could be saying absolute value. And you'll notice a little difference in the way this is described here on the video and the way that it's described in your textbook. And it's okay for you to latch on to the idea of absolute value. That's perfectly all right. I just want you to know that they're interchangeable in terms of practical use. All right, adding integers. Now here are our strategies for adding. We're looking first to see if the signs of the numbers being added are alike or unalike. If they are like signs, what we found earlier was that we just add the digits involved, add the absolute values, add the digits, and attach the common sign. You see, so add digits, attach the common sign. That's all there is to it. Unlike signs, we subtracted digits. Now, when I say subtract digits, I mean just intuitively, how do you think about that? Well, you're looking at digits only. You're not looking at positiveness and negativeness. You're just looking at digits. You're thinking of them as whole numbers. And when you subtract, it just means you want the difference. You want to take the number involved with the smaller digits, the smaller number from the larger number. That's the idea. So subtract digits, take the relative difference of their absolute values, if you will, but subtract digits and attach the sign of the larger digit. And that's what we discovered over here. All right, let's follow these rules in a few more problems. It's going to become relatively easy, I think. 8 and 5, we know that to be 13, and we can use our rules on this. That's pretty easy. We're adding a couple of positive numbers. This is understood to be positive 8, and that's understood to be positive 5. So the signs are the same. You add the digits and attach the common sign. The common sign is plus or positive, and the sign of 13 is understood to be positive or plus. Now, we can emphasize the idea it's not wrong to put a plus sign here. It's just typically not done, but it's not wrong to do so. All right, here we're adding a couple of negative numbers. The signs are the same, so we add the digits and attach the common sign. On these two, signs are different once again. All right, so signs are different. This is negative 3 with positive 7. Negative and positive number. We take the relative difference of the digits. So we're ignoring the signs for a moment. Take 3 from 7 to get 4 and attach the sign of the larger digit. The larger digit is understood to be positive, so this 4 is understood to be positive. Now, let's change it around. We have a positive 3 with a negative 7. The signs are different, so we take the relative difference. Take 3 from 7 to get 4 and attach the sign of the larger digit, and that sign is negative. So negative 4 is the answer here. Now, when the numbers get bigger, don't let the larger numbers intimidate you. The rules are exactly the same. You're just looking for like sign or unlike sign and get your head into the strategy for the solution to the problem. We have negative 15 with a positive 25. Signs are different, so subtract. We're taking the 15 from the 25. You see, so 25 minus 15, oh, that would be 10, and attach the sign of the larger one. It's understood to be positive. The 10 is already understood to be positive. Now, there wouldn't be any question about this, by the way, if we just use our commutative property. Remember that? The commutative property for addition means that we can add numbers in any order that we'd like. So suppose we just swap these around. So we'd have 25 minus 15. You see, it becomes a subtraction problem if we swap them around like that. But we're thinking of this in terms of addition here. Anyway, let's see. We're collecting here a positive number with a negative number. positive with negative. Signs are not alike, so we want the relative difference in them. That is, we want to just look at digits and take the number with the smaller digits from the number with the larger digits, if you will. So we're taking 162 from 247. We might do that off to the side. So we might come over here and say, okay, we're taking the 247 and we're going to subtract the 162. And when we do 7 minus 2 is 5. 4 minus 6 won't go. Borrow 1. That becomes 14 minus 6 is 8. So this is 85. So the relative difference in the digits is 85. We attach the sign of the larger. Oh, that's negative. So negative 85 is the result. Here's another one, negative 125 with negative 15. We are adding two negative numbers. The signs are the same, and this is the easy situation. This is the one where all we're doing is adding the digits and attaching a common sign. So we just take 125 and add 15 to get 140, and we attach the common sign, which is negative 140. Here's a problem involving 4 integers to be added. And we have talked about problems over here where we had only 2 integers at a time. You might have noticed also one other thing that I want to mention here is that for some of the problems over there, I worked them out to the right, put the answer out to the right. For other problems, I put the answer underneath. And it really doesn't make any difference. But when problems get more and more complicated, like this one, where we're going to have a number of steps involved in it, sometimes it's worthwhile to work below. And that's what I'm going to do here. Now, if we think about adding integers as being an operation involving only 2 at a time, then we would work this way. We would think from left to right. I'm collecting negative 2 with negative 7. So negative 2 with negative 7, oh, signs are the same. I'm adding the digits and I attach the common sign. And then I'll bring down the other part of the problem. Now don't try to work many steps at one time. This is a great time to learn how to organize problems by just performing one operation and bring down the rest of the problem. Then one operation, bring down the rest of the problem, and so on until you're done. So here, let's see, from left to right, we're going to add these two, negative 9 with positive 4. You see the signs are different, so we want the relative difference, the difference in digits. 4 from 9 gives 5, and attach the sign of the larger digit, it's negative, so negative 5, and then bring down the plus negative 6. Oh, here we have integers that have the same sign, so we add the digits and attach the common sign. So negative 11 is the answer. Now, some students looking at this problem might say, well, gee, isn't there a shortcut here? I mean, isn't it so much easier to add numbers, add integers, which have a common sign? Sure it is, because we're adding rather than subtracting. And if you think of it like that, then you could think, well, gee, I'd like to bring together all of the integers that have the same sign as much as possible. And what I'm noticing here is that I have 3 negative integers. I have negative 2, I have negative 7, and I have negative 6. And I can just about do that collection, that addition in my head because I'm just adding digits. You see, same sign, add digits. So we have 2 and 7 is 9 and 6, 15. So we have 15 and we attach the common sign, negative. And now we bring down the other term and collect these two. And now we take, let's see, signs are different. So we take 4 from 15 to get 11 and we attach the sign of the 15. It's negative, so negative 11. Here again we have 4 integers to be added, and we're going to add left to right, and then we're going to also take that little shortcut. Now, your teacher may not allow this shortcut. Even the teacher may want you to show all the steps and just do 2 integers at a time from left to right, and that's perfectly all right. That's good drill at this point. But going from left to right, we're thinking negative 5 with negative 2. You see, negative 5 plus negative 2. Signs are the same, so we add the digits and attach the common sign, and then bring down the other integers. And now, left to right once again, negative 7 with plus 9, with positive 9. So we have, let's see, signs are different, subtract. We have 7 from 9 is 2, and attach the sign of the larger one. It's understood to be positive, and this 2 is understood to be plus as well. So now I'll bring down the plus negative 3. aha, we have different signs. So we take the difference, 2 from 3 gives 1, and the sign of the larger digit is negative, so negative 1 is the answer. Let's see if we get the same result by taking a little shortcut here, by noticing that we have 3 negative numbers involved, and we can bring all of them together rather easily because the digits are rather simple. And we're thinking of these 3 integers, you see. And it's perfectly all right when you work problems like this to actually underline the items that you are that you're working on, and then you're identifying the numbers, the ones that you've taken care of once you're finished with that. But the signs are the same on all of these, so we're going to add digits. 5 and 2, 7, and 3, 10. So we have 10, and the common sign is negative, and we bring down the item we didn't work on. And now collecting these two, we have, let's see, positive and negative. Oh, we want the difference. 9 from 10 gives 1, and the sign of the larger is negative, so negative 1 as expected. Let's talk about subtracting integers. Now, we're familiar with a problem like this, 7 minus 3. It's just, if we think about subtracting whole numbers, this is just 7 minus 3, 4. And we could look at it on the number line. I mean, let's take a look at it right quick. 7 minus 3, gee, we can go up here and say, we can think, well, adding goes this way, subtracting goes this way, so 7 minus 3 would mean go from here, go over to 7, and then subtract 3 means come back this way, 3, 1, 2, 3. We end up at 4, as we would expect. All right, now, in the last little segment, we talked about adding integers, and we talked about if we have 7, and we're adding negative 3, when the signs are different, we just take the small digit from the large one, and we attach the sign of the big one. Oh, that would be positive 4. So really, these mean exactly the same thing. And in fact, we can say that subtracting is the same thing as adding the opposite. Now here, we're subtracting what? We're subtracting positive 3. We're subtracting plus 3 is the same thing as adding the opposite of 3, which is negative 3. So subtraction is the same thing as adding the opposite. Now, we're going to talk about some rules in just a minute, but I'd like for us to think our way through a few little situations before we go through some rules. And it's going to turn out that these two expressions are interchangeable with one another. If you like this one, if you prefer this one to that one, fine, you can change this one into that one. If you like this one rather than that one, then you can change this one into that one. You see, they're just interchangeable. And we'll look at interchanging them in just a little bit. All right, now look at these two kind of as a pair. 8 minus negative 2. Now, if you think about what we learned up here, that subtraction is the same thing as adding the opposite, then we can think of this, we can just rewrite it as 8 plus the opposite of negative 2. Oh, that's positive 2. So this is nothing more than 8 plus 2, or 10. Now, showing this on the number line is a little bit challenging because minus, subtracting, seems to imply that we go this way. But negative also seems to imply that we go this way. So what does it mean when we subtract a negative? You see, we have to come to some kind of conclusion about that. Now, we might think, well, gee, subtraction and negative, maybe it just means that we change direction when we think about those things. So we start out with 8 and we are going to subtract, so it means we come this way, but negative 2 means we change direction and go back that way to get 10. So it's a little bit difficult to think about this as movement along the number line. But it's real easy if we change this situation by using this idea that subtraction is the same as adding the opposite. Subtraction is the same thing as adding the opposite, you see. And you make that transition and it becomes a really easy problem. So this must be the same thing as 10. Okay, let's go through the idea. Now, I'm going to give you some choices here. and I want you to look at the examples that are in the textbook, and I want you to look at the way that the examples are done on the board here, and I want you to choose a method for yourself, because the method that I'm using here just gives you some choices compared to the ones in the textbook. It's not that one is right and the other is wrong or anything like that. Some students are comfortable with one way and not the other, and so you can just kind of take your choice. They all mean the same thing, though. That's what's important to realize. Now here, if we want to change this subtraction problem, you see this is saying, and I'll use parentheses here for emphasis, this is saying that we have -4 and we're subtracting 3. And if we want to, we can change this into -4 plus -3. You see, because subtraction is the same thing as adding the opposite. So it would be okay to do that, and we get -4 with -3. Oh, the signs are the same, add the digits and attach the common sign. So that's all right. But let me backtrack up here and let's look at the original problem. We know the answer is -7. Could we get there by just seeing through this idea of all of this adding of parentheses? Many of my students find that when you tack on parentheses and you tack on symbols and so forth, it gives an opportunity to make mistakes. And if we can see the whole situation just by looking at this without the parenthesis, then sometimes we'll make fewer mistakes. So we think of this as -4, and we know, we can anticipate that -3 or -3 means adding -3, you see. So we could actually think of this as -3. You see, because it can change itself into -3 like this. So we can think this is -4 with -3. Oh, okay, that's -7. And it's okay to think about it like that. Now, I am deliberately blurring the difference between minus and negative. I'm saying that minus and negative mean pretty much the same thing, that we can interchange those two ideas. So here, whether you interpret this as saying subtract 3 or add the negative of 3, it means the same thing. So we can think of this as -4 with -3, -7. I don't want to belabor it too much, but I want to belabor it enough to where we get the right idea. Let's go through it on this one. Now once again, if we want to, we can think of this as -7 with parentheses, and then we can think of this subtraction as adding the opposite of 8. You see, I'm thinking of that, and then subtracting 8 means adding -8. You see, and now we're collecting -7 with -8 to get -15. And I get -15 by adding 7 and 8 to get 15 and attach that common sign. But let's back up a little bit. Can't we get that same result if we just imagine that we have here -7, and we know this can change into -8, so let's just call it -8. You see, we're collecting -7 with -8. Oh, that gives -15, and we don't need to, therefore, make that parenthesis business. All right, now, I think what I'm getting at here is that a lot of times we can go through and simplify problems, in my view, by removing parentheses. We can just have a string of numbers that have signs, positive plus or minus signs in between them. And we can interpret those numbers as being positive or negative according to the sign that precedes them. Now, in a circumstance like this, where we have a parenthesis, we can drop the parenthesis like this. Subtraction means the same thing as adding the opposite. So this means the same thing as adding the opposite of -5 is +5. And I don't want to put a parenthesis with a +5, plus. You see, I don't need it because we can just write this. 15 and 5, oh, okay, that's really easy, that's 20. You see, the signs are the same, add the digits, attach the common sign. Similar thing happens here. We have minus, you see, and that becomes plus. And you can think of it like that if you want to. Minus becomes plus. Technically, though, this is subtracting means the same thing as adding the opposite. So this is -10 plus the opposite of -4 is 4. So we're really collecting -10 with +4. Signs are different. So subtract, take 4 from 10 to get 6 and attach the sign of the 10. It's negative. Now, let's talk about the rules that we're using here. It turns out that they are exactly the same as the rules that we used before. Now, I had this same set of two rules before when we talked about adding integers, and now I'm just going to label it collecting integers. We're bringing integers together, and I might even call this collecting signed numbers, numbers that have a sign in front of them. I'm collecting them, I'm bringing them together. I don't want to call it adding or subtracting, it's just collecting, it's bringing them together, because there's so many ways of interpreting what we see. I don't want to say adding or subtracting very much. But at any rate, it's the same idea. We have like signs, we add the digits and attach the common sign. We have unlike signs, we subtract digits and attach the sign of the larger digit. All right, when we have a string of numbers like this, I recommend that we simplify a little bit in those circumstances, especially where we have a parenthesis and we have a negative sign preceding it, a minus sign, a subtraction symbol. You see, if you want to interpret it in those ways, that we rewrite this as subtracting is the same as adding the opposite. So we want to say that this is adding the opposite of negative 12 is 12. You see, and now we have this. And we could think of subtracting 30 as adding the opposite of 30. But if we can see through that, then we can interpret this as negative 30. You see, subtracting 7 is the same as adding the negative of 7 or adding the opposite of 7. We, rather than burn a step and say this is adding the opposite of 7 is negative 7 and introducing the parenthesis, I suggest that we see this as a negative 7. We read it as a negative 7 if we want to. You see, so we have then, if we interpret the situation that way, then we have a negative 8 that we're collecting with a negative 30, that we're collecting with a positive 12, that we're collecting with a negative 7. Now, the numbers that have associated with them like signs mean that we can just add those values. So we have negative 8 with negative 30 with negative 7. Oh, same sign, add digits. 8 and 30 is 38, and 7 is 45. So we have 45 for the collection of all three of those, and attach the common sign, and now the plus 12. Oh, okay, different.